Hi, I'm Sydney. I am the author of From Whence Cometh Intelligence, and I am the proponent of the instrumentation of life theory. This entire effort is to correct something that I have noticed that is incorrect in our current theory of evolution. So I'm not saying that the evolution is wrong. We know that in 1859, when Sir Charles Darwin published his work, it's based on what he saw, what he observed. This is fact. By the way, 10 years later, Dmitri Mendeleev, in a dream, got the periodic table. And I think it's one of the biggest synchronicities that we missed. So anyhow, let me go back to the holes in the theory of evolution. Huge gaps. Because when it originally started, there was this whole concept of random evolution. We had this primordial soup and just chemicals and certain conditions, and out of that primordial soup, based on whatever was happening, we have this beautiful thing called DNA. That beautiful double helix that has all the genes and all that information that we can observe now. All of that came out of just random chemicals in this primordial soup. I think highly questionable. But anyhow, let's move forward. To today, what we observe is that evolutionary theory has gone to 4 components, because it started with, remember, random. Now, if you listen to any naturalist, or you look at any program that looks at things that are out there in nature, you hear 4 things. Well, actually, it seems like random, which started it all, has somehow taken a backseat. Now it seems like it has employed nature, it employs the will or the need of specific animals, and it also employs time. So you have 4 things now. 4. It went from random to 4 things. Random, nature, time, and apparently even the will of the animal. So, which is it? Now, I am the proponent of the instrumentation of life. And what that says is, people start, look at us. Let's go right back to the beginning, to the very, very beginning. Because what AI and robotics have taught us is that in order to make anything, to animate anything, autonomously, to make it work on its own or do anything on its own, you need sensors, or we may call them receptors, in living things. And so before you even create the first unicellular organism, you had to have sensors because it had to react to something. So this sensor now is the crux of this instrumentation of life theory, because there are 3 things you need before you can create a sensor. 3 things. 1, you absolutely must understand what the sensor is going to receive or monitor. So if you're making a light sensor, you must understand light. If you want to do something for smell or taste, you must understand the individual characteristics of all these chemicals. Like we have carbon monoxide sensor. Well, it's not doing nitrogen or H2S, all of these things. You have to understand. So when an animal is smelling or tasting, that means that sensor or that receptor is aware of the characteristics of that's whatever it is smelling or tasting. So for light, you have to understand light. Sound, you have to understand, pressure and vibration and all of these things. So you have to understand that, and that's just one part. The second thing is you must find materials that react to that stimuli in a way that is sort of proportional. So you can say, for instance, like temperature. It's something that expands and a certain rate, you can say, okay, when it's this big, it's this temperature. Same with light. So you have to find that material. You have to understand light. You have to find a material, and then you have to wire it up, which means you have to build that sensor. You have to connect it to something to process that information, because your sensors in your eye, for instance, does not close your eyes and make you wink, or close your iris, or contract or dilate, and all these things. It has to be wired to something else. So before you implement a sensor, you have these three things. You must understand the stimuli. You must know and find the resource that responds to it, and then you have to wire that up into a system. So, and this has to be done way back, not because we ate fish or we use fire. This is at the very beginning, before the first organism is created. So now it does make sense that the information about the sensors also has to be in DNA. So this is why in the instrumentation of life, you see everything ties back together to whatever intelligent, whatever force built that first sensor, then have to wire it up, is probably the same intelligent force that designed that beautiful DNA. Because the information about the sensor had to be there, and it all had to be wired up. Now, then that comes to what I call the DAP, or the DNA appropriate program. The DNA appropriate program. And you will say, well, then what, do you have a billion? No. A billion programs because you have a billion different species? No. If you've done programming, you know you can execute certain modules based on certain conditions. The conditions, so the DNA itself can be like a database, which it is. It contains all this information. The programming, the DAP, the DNA appropriate program, could respond based on what's in that database. And so the behavior of something relates to the configuration in the database. Now you see, these two are tightly coupled. So it makes sense that the designer, or the one who built the sensor and has to place that information in the DNA, would also build this program. And I know it sounds kind of like science fiction, but when we observe things, this makes logical sense, because we have advanced to that point where we are building, machine appropriate programming, right? That's our AI that will animate all kinds of things, whether it's a drone, a car, or some robot in your house. Again, so it has a machine appropriate program. Similarly, and this is all tightly coupled. It has to be. So now we don't have time, sometimes nature, sometimes the will of the animal, because this in us, we like to think of, well, I went to school and I learned this and I followed. No. When we talk about this refers to that intrinsic intelligence. Meaning, within us, think about our digestive system. Think about our immune system. Things that we do not control, but behave intelligently. Think about it. That's what within us. Let's confine it to that, because we do not control those things. Those would be the things that our DNA appropriate programming would control. And so you're like, okay, so we have, but that same program, again, it would be a large modular program based on who we are. Now, if you had 4 stomachs, or 3, or you ate grass, that program, certain functions or certain parts of that program would execute. So you don't have to redesign a new program for anything. You build this DAP, this DNA appropriate programming, and so certain functions, certain parts of it would execute based on information in the database, the DNA database. Now, when you get to having a brain and all that stuff, then you get into personality, you get into learning, all that stuff. But I'm talking about things like a spider. a fish, a bird that does not learn, especially spiders, you know, that does not learn from their parents. That's the intrinsic intelligence. That would be the DAP. So I'll go more into this, and I would love to have, naturalists go out there and they see things, but they bring this confusion, and it's very dogmatic. They say nature, 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 nature. Oh no! And then when he said, but this is a logical thing. Did nature go in? Going back to the example of that wolf that turned into a dolphin, did it slowly move? Who? Time, nature, the wolf, or random? Between them, they had a contract that says, let's just flip it on the head, or did we move it gently, or But again, if as a systems designer, I would say, no, if I know DNA, I can just say, manipulate this part of it and move that there, and modify that program or activate this part of the program, turn this off. And so this is where I say DNA appropriate. We don't see, for instance, a lizard trying to fly, because that part of the program that is not activated, you don't have the genes for wings. So that part of the program does not execute. Similarly, fish. So you see how this concept, this thesis, this theory applies to everything neatly, smoothly, just like the periodic table. In the periodic table, we have a nice layout of all these elements. We can predict, all of these reactions. We can predict them, except for catalysts, but we can learn that. But it's consistent. You don't hear, it's nature, it's time. Just leave it for a long time, and and just trust me. Just leave it for a long time, and it will happen. This beautiful double helix will form, or maybe because that had a form before nature came in, right? Because nature seemed to come in with the plants and the animals and all this stuff. But if you have an intelligent force that is absolutely required to design a sensor, then that sensor could be implemented throughout all life forms. Yes, plants respond to light. Matter of fact, again, almost all the energy from our foods ultimately comes from the sun, because it goes to the plants, and some animal consumes it. We consume the animal, we consume the plants, and that whole chain, right? So you had to first build the sensor, and to build a sensor requires intelligence because of the three things: knowledge of the stimuli, finding a material that responds in a predictable way to that stimuli, and then wiring that up. And so the very first organism that existed had to have sensors in it. And so this now today applies to everything. There is no changing. It's just this thing of, now that we know about programming and AI and machine learning, because it's not that thing of, well, it's constant, this is it. No, we know about machine learning now. We have this large database besides DNA. This is the part that we need, because with science, we want to be able to understand logically and be able to move forward. When we understand, we say, we expect to find this. Just like with a periodic table, we expect this element to have these characteristics because it fits here. With this theory of the instrumentation of life, we have to look at memory. We have to look at memory. Oh, and the DAP. I would also say the DAP must exist in the egg. Wherever there is an egg, no, we're not going with the chicken and the egg thing. We just say wherever there's an egg. If you think about an egg to a caterpillar, chrysalis, butterfly, the information, that DAP, even before there is a brain, because again, we like to say, well, the brain. No, not the brain, because the brain comes way later. When you think about a fertilized egg, there is no brain. And It's not random. What comes out of an egg, the process of cell division and forming all the organs that makes this new creature. There is no brain at inception, but that intelligence is there. That DAP, that DNA appropriate programming is already there. It has to be there, because if it's in the very smallest of organism, it has to be there in that egg. And so that directs. So regardless of what stage it's in, at cell division, it knows, okay, first I'm making a caterpillar. That DAP is in there. And so you would see that coupled with, if it's DNA appropriate programming, coupled with DNA. So wherever so this is where we need to start looking for this indication. And this is where it may not be this year or next year, but this is a consistent framework that can be scientifically checked going into the future, just like we look at black holes and all these theories, looking for this DAP, this DNA appropriate programming, something that directs things before there is a brain. When we look at all these animals and their intrinsic intelligence, not the stuff that you go to school and you observe, or the higher mammals that observe others and learn, not that. We're talking about the intrinsic, the ones that where they're things like imprinting. And again, I have a lot of these examples in my book, From Whence Cometh Intelligence, because when you see this theory fits in neatly with everything, just like the periodic table told us that these elements will be here and we can now predict going forward. So there was a time when we had to just speculate about what's missing, but as science advances and we put resources looking for this, we will find there may be corrections and adjustments, but this is a theory, the instrumentation of life, and moving away from the time, nature, random, and the will of an animal, causing it to change, because we can see that the tight coupling between the DAP and the DNA itself, and I go into details again in my book as to how that from each parent having certain, again, it goes back to those sensors, right? You have an imbalance caused by heat, by light, by food, whatever, and all that can feed back in to this DAP, which says, I am coupled with the DNA, so I can start initiating changes, because no animal changes itself. If it did, we would be masters of that. I myself would love to have, those eyes that I could see all day, all night. I would love to have that. And I would do whatever it takes. So we don't change ourselves like that. Right here, I would have, I could just push here out if we were like that. So it's that sort of thing. We have to recognize that intrinsic, that what I'm calling the DAP, the DNA appropriate program that dictates the unconscious part that sustains us. So when you go to sleep and all these things, the unconscious part. But we see it in animals from the time they are born. A spider spins web, a corolla spider knows quartz. So this is the part that fits neatly. That DAP has that information that dictates the behavior. That intrinsic intelligence is coded in that DAP. And so again, that is tied to the DNA. So you again appropriate programming to the DNA. So you don't find, again, unless you're a flying squirrel, but this flying squirrel knows that, because that programming is appropriate for the DNA, right? So think about this and compare this, and I would debate anyone, because what I find is they dogmatically say nature, and I says, well, no, fill in all the blanks. When I talk about the instrumentation, talk about a sensor. How does, at that point, there was no animal will, right? Because it sounds like the animal wants this, so it gets it. Well, at that point, there was no animal because you're building the first one. So only thing you had now was random. That's what we were taught. It was just random. And so somehow random figured out DNA and also figured out the building, the sensors that went with the very first organisms. And remember the three parts that has to go with building any sensor. You must understand the stimuli, you must find the appropriate material, and then you have to wire it up, because the sensor by itself does not do anything. It has to send that signal, it has to send somewhere where it's processed, and then that decides, okay, should I move right, should I move left? And I'm talking about, for instance, like an amoeba or paramecium or something like that, right? So that has sensors. And so the very first, so don't look at, we ate fish or we started fire. Really, you're talking about a billion years later, according to our evolutionary theory. So what is incorrect is that we started with random and now it does not fit anymore. The instrumentation of life, which leads us back to that intelligent creator. We must have had some intelligence to build the first sensor and to build all the sensors, which are everywhere. Every living thing has sensors, and it makes sense because building the sensors, building DNA, building the dam. Our AI, our science and our technologies has brought us to this point where we recognize that we can build a base intelligence and we can apply it and modularize it so that it fits in different things. And again, the example is based on what's in the DNA, certain parts execute, so that again, because it's appropriate to the DNA. So the behavior that occurs in any animal is tied to what's in the DNA because they're closely coupled together. And so you don't have to have a billion different, smart programming. And we're talking about really, really, masterful stuff that our technologists today, can do a lot of this if we had the DNA and we were able to probe, we could do it. And this is about behavior. And I'll go into a lot of these things. So what I would like to do really is to address a lot of these things where the naturalists go out there and it says, well, this and this and nature, and it gets you into this area where you're not sure, is it nature, is it the animal, is it time, which I want to show exactly how the depth can accomplish the same thing, and with a consistent from the very beginning all the way to the most complex. Okay, so I'll be continuing the series of programming life, and so keep checking it out, and hopefully I can get outside, with a team and do like these naturalists do and point things out. But for now, I will be spending more time in going into the fundamentals of this and ultimately taking it out there. So once again, I'd like to thank you for taking the time. I'm sitting and pick up a copy of the book, right? Because that goes into more detail than I speak about here. So thanks again, and until, take care.